Section 358.4 addresses offsets in electrical metallic tubing, often referred to as EMT. This section provides specific guidelines on how to properly create offsets when transitioning EMT into enclosures or boxes, such as when coming off a wall. It's important to adhere to these guidelines to ensure a safe and code-compliant electrical installation. When dealing with straight offsets in EMT, Section 358.4 dictates that these must be made using couplings and nipples. The nipples used should be of standard length and, importantly, should not exceed 3 inches in length. This limitation on nipple length helps to maintain the structural integrity and support of the conduit run. In contrast to straight offsets, bent offsets in EMT are addressed in Section 358.4 D2. This section states that bent offsets are achieved by cutting the conduit to the appropriate length and then bending it to the required angle. A crucial aspect of creating bent offsets is the bending process itself. The bend must be made using a bending device specifically designed to produce a smooth and uniform curve. This ensures that the conduit is not damaged or weakened during the bending process. Furthermore, the radius of curvature of the bend is subject to a specific requirement. It must not be less than 6 times the trade size of the conduit. This minimum radius helps to prevent kinking or flattening of the conduit, which could reduce its internal area and potentially damage conductors. The NEC provides similar guidelines for offsets and other types of conduit as well. For rigid metal conduit, or RMC, offsets are typically made using bends, elbows, or nipples. When using bends or elbows, they should be of standard, rigid, or flexible type, and the radius of curvature must be no less than 6 times the trade size of the conduit. Nipples, when used, should also be of standard length and not exceed 3 inches. For intermediate metal conduit, or IMC, the requirements are similar to those for RMC. Offsets are made with bends or elbows, and the radius of curvature should be at least 6 times the trade size of the conduit. When it comes to PVC conduit and tubing, offsets are made using bends or elbows. The bends or elbows should be of standard, rigid, or flexible type, and the radius of curvature must be no less than 6 times the trade size of the conduit or tubing. An exception exists for liquid-tight flexible metal conduit. This type of conduit is permitted to be offset without the use of fittings, provided certain conditions are met. Firstly, the total length of the offset must not exceed 2 feet. Secondly, the offset itself should not be longer than 2 feet. Thirdly, the offset must be made with a sweeping bend. Fourthly, the radius of curvature of the bend must be no less than 6 times the trade size of the conduit. And fifthly, the offset must be properly supported in place. Now let's discuss the general requirements that apply to offsets as outlined in Section 358.4a. This section states that the total length of the offset should not exceed the length of the conduit or tubing that it replaces. Additionally, the offset is not required to be longer than 3 feet. These limitations help to ensure that the offset does not introduce excessive stress on the conduit or the enclosure to which it is connected. Furthermore, maintaining proper grounding and bonding is crucial when installing metal conduit. While Section 250.4 FIV addresses grounding principles, it may not be the most directly applicable article for offsetting conduit. However, it's essential to ensure that the conduit system is properly bonded to maintain a continuous ground path. A properly installed offset can compromise the grounding and bonding of the system, which could pose a safety hazard. Poor workmanship in electrical installations can lead to a variety of problems, including code violations, safety hazards, and reduced system performance. It's important to adhere to the NEC guidelines and best practices to ensure that electrical installations are safe, reliable, and compliant. If you observe substandard work, it's important to address it through proper channels, such as reporting it to the relevant authorities or providing education and training to those responsible. By maintaining high standards of workmanship, we can help to ensure the safety and reliability of electrical systems. Let us delve into the specifics of each conduit type and the associated offset requirements to provide a more comprehensive understanding. Firstly, let's consider rigid metal conduit, or RMC. This is a heavy-duty conduit often used in applications where mechanical protection and a solid grounding path are required. When creating offsets in RMC, the NEC permits the use of bends, elbows, or nipples. If bends or elbows are employed, they must adhere to specific standards. They should be either standard, rigid, or flexible type. More importantly, the radius of curvature of these bends or elbows must be carefully controlled. The code mandates that the radius of curvature should not be less than 6 times the trade size of the conduit. This requirement ensures that the bend is gradual enough to prevent damage to the conduit and maintain its structural integrity. When nipples are used to create offsets in RMC, they should be of standard length and not exceed 3 inches in length. This limitation on nipple length is intended to prevent excessive stress on the conduit and the connected enclosures. Secondly, intermediate metal conduit, or IMC, is a lighter weight alternative to RMC, offering similar protection but with reduced weight and cost. The rules governing offsets in IMC closely mirror those for RMC. Offsets in IMC are typically made using bends or elbows. As with RMC, these bends or elbows must have a radius of curvature that is no less than 6 times the trade size of the conduit. This ensures the smooth, gradual bend that does not compromise the integrity of the conduit. Thirdly, electrical metallic tubing, or EMT, is a thin-walled conduit commonly used in protected locations. The rules for creating offsets in EMT differ slightly from those for RMC and IMC depending on whether the offset is straight or bent. For straight offsets in EMT, the NEC requires the use of couplings and nipples. The nipples used should be of standard length and not exceed 3 inches. This method is suitable for small offsets where a minimal change in direction is needed. For bent offsets in EMT, the process involves cutting the conduit to the appropriate length and then bending it to the required angle. This bending must be performed using a bending device specifically designed for EMT. The bending device should produce a smooth, uniform curve to prevent damage to the conduit. The radius of curvature of the bend must also adhere to the 6 times the trade size rule, ensuring a gradual and structurally sound bend. Fourthly, PVC conduit and tubing made from polyvinyl chloride is a non-metallic conduit often used in corrosive environments or underground applications. Offsets in PVC conduit and tubing are made using bends or elbows. These bends or elbows should be of standard, rigid, or flexible type. The radius of curvature must be no less than 6 times the trade size of the conduit or tubing. This requirement ensures that the bend is gradual enough to prevent kinking or flattening of the PVC, which could reduce its internal area and potentially damage conductors. Fifthly, liquid-tight flexible metal conduit offers flexibility and protection in wet or hazardous locations. The NEC provides a specific exception for offsetting liquid-tight flexible metal conduit without the use of fittings, provided certain conditions are met. The total length of the offset must not exceed 2 feet. The offset itself should not be longer than 2 feet. The offset must be made with a sweeping bend. The radius of curvature of the bend must be no less than 6 times the trade size of the conduit. The offset must be supported in place to prevent sagging or damage. Electrical metallic tubing requires the use of flexible elbows or bending the tubing to the required angle. Flexible elbows must be listed for the purpose, indicating they meet specific safety and performance standards. The radius of curvature of any bend must be at least 6 times the trade size of the tubing, ensuring that the bend does not compromise the conduit's structural integrity or the conductors within. Offsetting conduit involves more than just bending or fitting. It also requires careful consideration of support and securement. The NEC mandates that conduit be securely supported to prevent sagging or displacement. The specific requirements for support spacing vary depending on the type and size of the conduit. Proper support is essential for maintaining the integrity of the conduit system and preventing strain on connections. Furthermore, it's important to ensure that all fittings and connectors used in the offset are properly listed and labeled for the intended application. Listed and labeled equipment has been tested and certified to meet specific safety standards, providing assurance of its quality and performance. Using non-listed or improperly installed fittings can compromise the safety and reliability of the electrical system. In addition to the specific requirements for offsetting conduit, it's important to consider the overall design and layout of the electrical system. The goal should be to minimize the number of bends and offsets required, as each bend introduces additional resistance and can potentially reduce the ampacity of the conductors. Careful planning and coordination can help to optimize the conduit routing and minimize the need for excessive offsets. When working with electrical conduit, safety should always be the top priority. Before starting any work, ensure that the power is turned off and locked out to prevent accidental energization. Wear appropriate personal protective equipment, including safety glasses, gloves, and appropriate footwear. Use tools that are in good condition and properly maintained. Follow all applicable safety procedures and regulations. Failure to adhere to safety precautions can result in serious injury or even death. Code compliance is not just a matter of following the rules. It's about ensuring the safety and reliability of electrical systems. The NEC is developed and updated regularly by a committee of experts who consider the latest research, technology, and best practices. Adhering to the NEC helps to minimize the risk of electrical hazards, such as fires, shocks, and electrocution. It also ensures that electrical systems are installed in a manner that is consistent with industry standards and best practices. In conclusion, offsetting EMT, rigid IMC, and other types of conduit requires careful attention to detail and adherence to the NEC guidelines. Understanding the specific requirements for each type of conduit, as well as the general requirements for offsets, support, and grounding, is essential for ensuring a safe and code-compliant electrical installation. By following these guidelines and best practices, you can help to maintain the integrity of the electrical system and protect people and property from electrical hazards. Remember to always prioritize safety and seek guidance from qualified professionals when needed. The National Electrical Code, or NEC, provides a comprehensive set of rules and regulations for electrical installations. These regulations are designed to ensure the safety of people and property by minimizing the risk of electrical hazards. The NEC is updated every 3 years to reflect the latest technological advancements, research findings, and best practices in the electrical industry. It is essential for electrical contractors, engineers, and inspectors to stay up to date with the latest edition of the NEC to ensure compliance with current standards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Understanding the NEC is crucial for anyone involved in the design, installation, or inspection of electrical systems. In addition to the NEC, many local jurisdictions have their own electrical codes and regulations. These local codes may be more stringent than the NEC or may address specific local conditions. It is important to be aware of and comply with both the NEC and any applicable local codes. Failure to comply with electrical codes can result in fines, penalties, and even legal action. It can also create safety hazards that could lead to serious injury or property damage. Therefore, it is essential to take code compliance seriously and to seek guidance from qualified professionals when needed. Electrical inspections play a critical role in ensuring code compliance and safety. Electrical inspectors are responsible for verifying that electrical installations meet the requirements of the NEC and any applicable local codes. They conduct inspections at various stages of the construction process, from rough wiring to final completion. Electrical inspections help to identify potential hazards and code violations before they can cause problems. They also provide an opportunity for contractors to correct any deficiencies and ensure that the electrical system is safe and compliant. If you are planning to have electrical work done, it is important to obtain the necessary permits and schedule inspections with the local authorities. This will help to ensure that the work is done safely and in compliance with all applicable codes and regulations. When working with electrical systems, it is essential to have a thorough understanding of electrical theory and principles. This includes knowledge of voltage, current, resistance, and power. It also includes an understanding of how electrical circuits work and how to troubleshoot problems. A strong foundation in electrical theory is essential for safe and effective electrical work. There are many resources available for learning about electrical theory and principles. These include textbooks, online courses, and hands-on training programs. Investing in your electrical education can help you to become a more skilled and knowledgeable electrician. It can also help you to avoid costly mistakes and ensure the safety of yourself and others. In addition to theoretical knowledge, practical skills are essential for electrical work. This includes the ability to properly install wiring, terminate connections, and use electrical test equipment. Practical skills are developed through hands-on experience and training. Apprenticeships are a common way to gain practical skills in the electrical trade. Apprentices work under the supervision of experienced electricians and learn by doing. They also receive classroom instruction to supplement their on-the-job training. Apprenticeships provide a structured pathway to becoming a qualified electrician. Continuing education is important for electricians to stay up to date with the latest technologies, codes, and best practices. The electrical industry is constantly evolving, and it is essential to keep learning to remain competitive and effective. Continuing education courses are available on a wide range of topics, including new wiring methods, energy-efficient technologies, and safety procedures. Many states and local jurisdictions require electricians to complete continuing education courses to maintain their licenses. The electrical trade offers a rewarding career for those who are passionate about working with electricity. Electricians are in demand in many parts of the country, and the pay is generally good. Electrical work can be challenging and rewarding, and it provides an opportunity to make a positive impact on the community. If you are considering a career in the electrical trade, it is important to do your research and make sure that it is the right fit for you. Talk to electricians, visit job sites, and explore apprenticeship opportunities. With hard work and dedication, you can build a successful career in the electrical trade. Finally, remember that electrical safety is everyone's responsibility. Always follow safety procedures and regulations when working with electricity. Report any hazards or code violations to the appropriate authorities. By working together, we can help to ensure the safety of ourselves and others.